Well, hello everybody. Welcome to the Trusted Autonomous Systems Defence Cooperative Research Centre's Training for Autonomy webinar. We were originally planning to have this at a symposium in Townsville in May and to have a lot of speakers speaking on a lot of different issues to do with autonomy. But I'm glad to say we've been agile in the COVID-19 crisis and we've been able to run ethics and law workshops in the preceding 4 weeks. And I'm really delighted today that we have two of our speakers who are going to come to Townsville, be able to be present with us to talk about training, because I think their topic is an exciting one and an opportunity for a lot of change and development in serving personnel of the ADF and in defence more broadly. But before we get into the excitement of the content, I would like to acknowledge the traditional lands on which I am sitting at the moment. The Turrbal and the Yagara people as the First Nations owners of the lands. And I just wanted to pay respect to their elders, laws, customs and creation spirits. We recognise that these lands have always been places of teaching, research and learning and cooperation. So we are very grateful for this opportunity, and the way that it's going to work today is you're welcome to ask questions in the chat bar, but because we are anticipating quite a lot of people, we're not going to let people speak, but I will chair in terms of translating your questions from the chat bar to the speakers. Each speaker is going to speak for about 15 minutes and then about 10 minutes for questions for them. And then we'll have a wrap up at the end in terms of just thinking about training and autonomy into the future. And if you have any questions and you were unable to have them answered today, I do encourage you to reach out. And I'm hoping the speakers don't mind me suggesting they reach out to you, the speakers, with regards to your questions. And certainly you're welcome to contact the CRC to connect up to the people here today. So without further ado, I'd like to introduce Ben Rice. Ben, take it away.
G'day, Kate. Yeah, thanks for that. And thank you very much for having me, Kate. And thanks to the Defence CRC for Trusted Autonomous Systems for inviting me to speak today. It's rare you get to talk to such a distinguished audience like this, particularly sitting in a chair in a room, which is relatively unusual. For those, my name is Benjamin Rice. I'm a former serving Air Force aviator and the founder of Coherics. When in uniform, I was mainly on the operational platform, the E7 Wedgetail. But I spent a significant part of my career in the training domain, both delivering training content to aspiring aviators and assisting research and development programs with defence science and technology, mostly into future training systems and live virtual and constructive integration, or LVC, for those that follow 5th gen catchwords. So I'm here today representing my company Coherics, which I co-founded to offer high-end training solutions, systems and products to defence and defence industry as a primary function there. And Kate's asked me to talk a little bit today about training to accelerate the adoption of autonomous systems and to talk about the future of warfighting with autonomous systems as well. It's a bit of a mouthful, and I'll try to keep the jargon as low as possible, mostly because I forget what the jargon is as much as everybody else does. And also I really want to keep this as high level as possible. I want to talk about future states and where those domains are going, in my opinion. So my ultimate aim today is to describe that future state and how we could potentially get there and what the role of the training systems and training innovation will play in that. So firstly, I want to talk a little bit about the early 20th century. And there was an American inventor called Elmer Sperry. He developed the gyro compass. This device used the rotation of the Earth together with a spinning wheel to point towards true north. A lot of people will be familiar with that if they're in aviation or maritime. This device offered a great advantage over the magnetic compass for maritime navigation, since the performance of the gyro compass was mostly unaffected by its proximity to metal objects. Some years later, in the late 1920s, Sperry also developed the gyro pilot. This device used the gyro compass coupled together with a steering mechanism to create an automated course keeping function on ships. This was gleefully adopted by the US Navy and the crew of the first fitted ship called the Gyro Pilot Metal Mike. And that's a term quite a few of you might be familiar with if you come from this domain. And it emulated the commands of a helmsman. So for me, this is where the inception of applied automation sort of comes from. It seems like a bit of a naff place to start a presentation, But I can't help but think that people would have been a little bit skeptical of this then new technology steering their ship for them. It's been about 100 years since metal mic was adopted to the US Navy ships, and since then we've seen a huge array of autonomous systems that are vastly superior to that of metal mic applied from up in the high-end warfighting domain all the way down to our daily lives. But instead of jumping from 1920 to now, allow me a little bit of artistic license, and this is dangerous, to go a little bit forward in time and maybe a few decades or even more in time. Hopefully sometime when I'm sitting on a beach, preferably with a beer. It's your first day in uniform. It may be the military, it could be civil law enforcement, but something like that. Besides a questionable haircut, because some things never change, you get issued with your uniform and start the arduous process of learning to march. Along with the uniform, you are issued with an ID chip. This chip is inserted into your newly issued glasses, but unlike the smart glasses of today, these are a little bit different. These glasses unlock your ultimate buddy system. Your ID chip is key to allow your access to your own virtual teammate, by which I mean a smart, artificially intelligent system or entity that exists in a cloud of virtual teammates that you can directly interact with. You aren't the only person that has a virtual teammate. Everyone has one. Everyone is wearing these glasses. And as you retire to your room on your first day, your teammate introduces themselves to talk about your first day in uniform. The voice seems a little bit like Hal from The Genius of Stanley Kubrick, but hopefully a little bit less creepy. And you tell them a little bit about yourself and your likes and dislikes, and you get to know each other. And it's a bit like getting to know any other cadet in your living quarters. And I'm sure a whole lot of people in the chat room today may have experienced this as well at some point in their time. Only this one doesn't have a face yet. Now, I'm sure this seems probably a little bit ridiculous, and maybe I'm being a little bit far-fetched here, but it's not. Your teammate needs to be your partner, and they're going to be with you for a really long time. At every opportunity, your teammate is learning a little bit about you and is speaking with a database of every military member that's currently serving and has served before you to best structure your learning plan for tomorrow. Your tailored solution that best fits your current situation, your strengths and weaknesses, and puts you on the right path to competency and mastery as a warfighter or a law enforcement officer. Your virtual teammate is learning the type of voice and face that you best respond to, not the one that you may like the most, but potentially the one that you respond to the most in the most effective manner. So while in basic training, your virtual teammate will help you study for your tests and will structure your lessons in an optimized way that is best suited to your training transfer. As you graduate and move forward towards your initial employment training, your virtual teammate comes with you. It stays in your classes and it remains with you, and it's starting to learn you and how you work quite well. It learns how you best learn, how you interpret feedback, and how to best improve on your weaknesses. So by this stage, your teammate may have a face. The system could be geared in such a way that we can impose a real human or a virtual human that could sit next to you, that you could interact with and have a conversation with. Now, this seems ridiculous to us, and it would look really weird as an outsider to see a person talking to somebody who doesn't exist, but everyone has one. Everyone's doing the same thing. And those virtual teammates are all communicating with each other to share that knowledge between them. So your teammate knows the curriculum and the desired competency standards for your initial employment training course. It knows that you're going to find some parts of that hard and some parts of that course easy. And so it speaks with the virtual teammate of your human instructor or your human expert at the schoolhouse and develops tailored lesson plans that suit you. Your teammate also knows that they may one day see combat with you or potentially a situation that we're seeing on the streets at the moment where there's a conflict between police and civilians that needs to be handled very delicately. And so it's slowly testing your resolve in certain situations on a daily or somewhat regular basis to try and predict your behavior in the heat of the moment. Because if it knows it can predict your behavior, it will know the kinds of information that you will seek and when you will seek it when everything turns to chaos. When the time comes for your conversion onto your aircraft type or your ship or your warp fighting platform or whatever that may be, potentially a team, your virtual teammate again knows the curriculum and how to produce course content and lessons that optimize your learning and reduces the content that you just simply don't need. It may sound like I'm describing a future where you're paired with like a virtual R2-D2 or C3PO. I am. The future of warfighting won't be humans commanding machines, it'll be humans collaborating with machines to optimize the human in the warfighting or law enforcement system. Now, this isn't just a pipe dream that I've just made up just to sound like a great storyteller, which I'm sure you're all saying this guy's a great storyteller. This is a real and designed future state, and one shared by several people and quite a few researchers. I've got to pass some credit for this off to Dr. Chris Best at DSTG. I know they've been looking at this sort of idea for quite some time. But what does this all mean? If we can build machines that are so smart, why don't they just go and fight the wars for us while we enjoy sitting at the pub? Well, this is certainly a possibility, I suppose, but the idea of robots fighting our wars removed from any human element is, I think, really unlikely. I mean, due to time constraints today, I've only got 15 minutes, so I won't delve into that subject on its own. But if you do want to talk to me about that and my thoughts on that, just reach out. I'm more than happy to have that conversation at any time. But I think we will find a collaborative approach where humans and machines work together in real time to deliver the capability demand that's required of them. The virtual teammate is just one idea, sure, but there certainly are others. But to me, this seems like the ultimate goal. And of course, a lot of people will have opinions about whether or not this is a state that they desire, and I strongly encourage you to do so. But from my biased experiences, both a military aviator and an officer, it is. To have my own teammate that follows and grows with me and learns with me throughout my training, from my daily tasks and operations and also to the battlefield, sounds like a really amazing partnership. It's one we try to form with people right now. And not only that, the virtual teammate is growing and learning and imparting my lessons back into the system to share with others, to increase that training transfer and to increase the overall efficiency of the system. So let's call this virtual teammate or virtual droid the bullseye on a dartboard, surrounded by other great ideas that we should chip away at to get to this desired end state. So when you throw your figurative dart, it beds into something close or at least on the path that we can hone towards this goal, if it's so desired. So how do we get there? What do we do now to get to this possible future state? I mean, it won't be easy. A bit like Metal Mike, it's going to be really hard to develop and probably hard to trust for even the most experienced of operators. Yep, I agree. I think it's really going to be hard. So how do we do it? Firstly, we need to develop AI that can learn and interpret with human counterparts. This may be a contentious issue to some, and I can understand why, because having an artificial entity predicting your behaviour, it may be concerning to some. And I think that debate is warranted. And I'm just going to buy out of that immediately and pass that off to great minds like Kate to work in the ethics space of whether or not that's a nice little cheeky throw to you there, Kate, and whether that's something that we should actually aim for. But the work on this is already underway. A lot of you will be familiar with the work of the Teslas and the Googles of the world, but look to the work of Professor Mike Richardson of Macquarie University. Mike and his team have been chipping away for years at creating AI systems that can learn and teach human participants in simple games. Some of these games are often referred to as Mike's sheep herding games, which I'm sure has nothing to do with the fact that he's Kiwi. But in these games, the players put on VR goggles and they herd virtual sheep in a virtual board to either move sheep to a point or away from a point. And the best part about that research for me is that the humans that are participating in that pass the ultimate Turing test where they don't know if the other participant was a human or a machine. And the human is training the human is training the machine, and likewise machines are training humans. Secondly, we need to work on the integration of learning curriculum into AI systems, where the system captures the performance of human participants and recommends to the expert human instructor not only where the student performed at or below standard, but what lesson could be constructed for tomorrow in order to best remediate and deliver these competency standards. Work on this is already being done in institutes like Deakin University's Applied Artificial Intelligence Institute. But it requires input from expert trainers to validate these decisions and recommendations of the AI system. It also raises a pretty good point or question about human and machine state monitoring, or how does the machine know what state the human is in? Not just is the human stressed, happy, sad, or angry. If we're looking at military operators, angry probably. But what are the humans in this state doing? Are they in a synchronistic state between the other humans in this system? Are they demonstrating any shared understanding or, more importantly, lack thereof? Also, are the humans aware of the state of the machines they're collaborating or commanding? Work on this has started, and it's being led by a group of magnificent researchers at DST and Fisherman's Bend, but there's more work to be done. And I think lastly, we need to consider how we begin the transition to and integration for trusted autonomous systems. The training domain is ripe for disruption. Bingo to anybody who's playing buzzword bingo at home. Don't lie, I know you are. But it will likely be the training domain that will carry the burden of assimilating and transitioning this technology into service. It'll be the training experts and the scientists and the engineers and the warfighting and law enforcement specialists that need to work together for this technology end state to come to fruition. And they are, and we need to continue to do so. Further collaboration is absolutely just a must in that area. And it's because of this that we need to treat these systems like a job description. We need to think of them not as a computer program, but an actual role that holds responsibility and competencies in a system, just like any other operator or expert. However, I guess unlike a military or law enforcement operator, the output to these autonomous systems is likely to be an input to the human operator who has a warfighting output. And so their job descriptions and roles and the analysis that needs to go into that needs to be really measured and considered. And it raises some interesting questions. And these are questions that I think about all the time, probably because I'm a training nerd. But these are the sort of things that I'm working toward, that we're trying to deliver in our domain. Questions like, how do we conduct a task analysis on an artificial teammate? How do we control for an autonomous system or a virtual teammate's variability due to the uniqueness of the human they're paired with? How do we develop systems that are designed to assist a trainee learn a specific competency set whilst designing completely tailored lessons that are hard to contrast with other humans undertaking the same training? Not unlike the current application of RPL and RCC, but in a way that may be hard to monitor. Can this really, truly be standardized, and should it be? And do we actually lose something about the camaraderie of the military experience if we're to separate everybody's learning experience from everybody else? I mean, so clever learning management systems need to be developed that can begin to adapt with trainees and grow with them and learn with them to find efficiencies in training. And also learning the capabilities of our new autonomous systems and what responsibilities can be removed from the human warfighter and transition to that of a virtual teammate. Also, methods and procedures need to be created that enable trainees to experience autonomous systems and build trust with them. I mean, it sounds challenging, but as a concept, we kind of already do this every day. I mean, everybody here has probably been or had a new junior member join their team or a new trainee come on board, and you probably haven't let them loose immediately without some sort of supervision. Everyone needs to build their trust with those around them, and we'll do the same thing with autonomous systems. Now, I've kept this all really high level, and I haven't gone into a whole lot of detail here, mostly because of the time constraints. But if anybody wants to talk more about this, I'm more than happy to continue this conversation at any time. But I've tried to detail a future state that we're moving towards. And feedback from the warfighting and law enforcement community is not only welcome, but encouraged. Yeah, please sing out. And none of this is going to happen in isolation. It's going to be a really iterative approach. And over a long time, it's going to be through these partnerships with the warfighters and the research and development communities, both public and private, industry like myself, and operational trainers. And I think without these elements working together, we're going to struggle to see that end state. But I think the idea and the concept of a virtual teammate is going to be essential to the future fighting force. Thanks, Kate. Do we take questions now, or can we...
Yeah, we'll take some questions. So I've got one from Kate Bevan. She said, becoming a trainer is a significant component of category progression for the warfighter due to the increased level of system and operational knowledge required. It also improves the ability of operators to mentor junior members as they move into the more senior positions. Is there consideration for the impact on this component of development with the introduction of autonomous training?
Yeah, okay, there's a couple of elements in there. I guess the first one is that if in the end state that I've sort of put forward for that sort of 30 to 40 year mark, you might find that we accelerate the path from initial entry and not yet competent to competency to mastery. And the part that a human expert will play in that system will probably not change in a huge way, because there will still be a place for human experts to be paired with their expert virtual system. And I think we don't want to remove the element of the human out of the warfighting space at all. And this is one of those things I didn't want to delve too much into about if we don't have the responsibility of war, then there's a huge ethical boundary about what we can and can't do in that space. And I think we'll see things in a very different way. So the progression of ab initio to competent to on the path to mastery, and then you start giving back into that system is really essential. And I don't think that will change. I think that's half answered that question a little bit, Kate. Did you want to expand on that a little bit more?
Well, maybe we'll ask the next question, Ricey, and we can come back to that, or Kate can send a follow-up if she'd like some more clarification or to progress it. This from Mike Moroney. He said, what does industry and academia see as the barriers to implementing AI into defence, and what does industry believe defence can do to reduce those constraints?
Yeah, good question. I mean, obviously one of the big barriers is security. It's a bit of a throwaway line because everyone says, well, security is a big barrier, right? But unfortunately it is, because the more data that we capture on the specifics of people and their performance, the more we put ourselves ready to be exploited on that as well. And that's something that you want to have more data on your people, and that's how we can get to things like truly adaptive learning systems, where we can start to structure an individual's performance and their next lesson, knowing what we know about them today, to map them across time and to get them through certain competency gates to get to that required state. And that's something that's relatively possible right now. The problem is, as you have more data on that, you've opened yourself up to exploitation on not only the performance of the system or your warfighting platform, but also the people on that system. And so I think there needs to be strict adherence to the data standards and the interface between that data and the military operator in order to break those barriers down.
That's great. Okay, Bestie's come online. Look out. You ready, Ricey?
Yeah, sure.
He said, great brief, Ben. Do you think, I've got to use his voice. Do you think there might be some types of training more suited to the involvement of agents as trainers or teammates than others?
Yeah, I think absolutely there would be. I think as we move towards adaptive systems that want to tailor the lessons for those people, there'll also be the way to tailor how that person best receives that learning and in what environment they receive that training transfer the best. It shouldn't be any surprise to anybody that people are all a little bit different from each other, and we all have our own sort of individual needs, wants, and things that we react really well to and things we don't react very well to. I mean, a classic example is some people love forceful, abrupt feedback and they'll just go and remediate those things. And some people would like a more gentle approach where it's more suggestive and the trainee can get to their own conclusions with a nice, calm, gentle way. And that's something we can use to structure those lessons and to build systems that adapt to the person and the individual to meet those required standards.
That's great. So Wink Bennett says, one long-term implication of greater human-machine integration is the need to train the machine how to work collaboratively with humans. Eventually, the machines will need to understand their human teammates. Any thoughts on how this might look like, or what this might look like?
Great question, Wink. And good to see you online. It must be like 2 a.m. where you are, mate. Yeah, that's a really good question. So I think the machines are going to have to understand their humans. And there's the first barrier to get through is how does the machine monitor the human state? And like the work that's been going on with DST, and I know AFRL, there's that state monitoring where, amalgamating or synchronizing arbitrary data streams help to build a picture of the performance of that human. And the second part of that question, Kate, was, sorry, I've forgotten.
I guess how to understand their human teammates. I think that's work collaboratively and understand humans. I think those are the two component parts of the question.
Yeah, so I guess, so yeah, work collaboratively and understand. I mean, I see a bandwidth problem as one first boundary of how much data can you get off a biological system into a machine, and through what means can you get that information. And once you can get that together, then you can start to find where certain signals mean certain things, and we can start to, over a long period of time, work that together. And I think that's going to be a big challenge.
That's great. One last question for you from Kaustubh Krishnamurthy. What kinds of technologies would you consider critical in order to implement this kind of feedback and training system? How mature do you think they are today?
Yeah, so they're maturing. There is starting to be systems developed and implemented now of adaptive training, where we look at training courses and systems where we have a known starting point and a known competency end state, and the individual trainee's path from here to the end could look very different from somebody else. That maybe there's 100 lessons and I do a subset of 57 of those and you do a subset of 60 of them, but we both got to the end, both less than 100 lessons in, because we tailored those to our individual needs. How mature is that? Yeah, it's developing. There's a lot more work that needs to be done that we're trying to do now about, well, what metrics can you apply over those systems in order to get the right data to structure the next lesson? And how do you have a flexible curriculum when you've got very rigid competency standards? So it's developing is my really vague answer.
That's great. I'm going to call an end to your questions now, but I will come back to the questions as they're asked by the end of the hour if we have time. So thanks everyone for your questions, and thank you so much, Ben, for your presentation. I'll now hand over to Ross, who will use visuals that are more than his face. Thanks, Tracy.
Thank you very much. I'll just share my screen. So I'm going to go straight to your standard system. Thank you. Come on. Start. Now, thank you. Thank you very much, Kate, and your team for inviting me to talk here. Just to give some context, I guess I'm not a defence contractor or somebody from the defence background. I work at a university, so I'm one of those academics. Kate has invited me to talk about some ideas that we were putting together around this space. And so the ideas that I work in, just quickly to introduce myself, I work in as a Bachelor of Games course coordinator at QUT. So my space is around looking at immersive systems in virtual reality and augmented reality. Around 30 years experience in 3D computer graphics, virtual worlds, games. We also run a research group called CLEVER, Cognitive and Learning Environments in Virtual and Augmented Reality. And yes, that's an image drawn by my PhD student of me floating in the air. Because he says that I often sit there in meetings staring off into the distance like I'm meditating. So I come from this background. My space is around human-computer interaction or computer-human interaction, depending upon which country you come from. They use the acronym differently. And so the idea today is to maybe, I'm probably going to do a detailed use case of how to do this now, using what we have available with us and some of the gear that you see sprinkled around me in my room here, and how we can use that for a particular use case. I've been working with a local company in Brisbane. But this points towards the future of training, points towards the future of garnering data from people, and points towards how we're going to do these sort of training and verification systems. So where did this come from? The inspiration was from talking to a local company, Skyborne Technologies and Cyborg Dynamics. When we were discussing, the use of drones in the military, in particular armed drones in the military. And they have a particular system that they are interested in developing around an AI drone operator system, where the machine learning is mediating between the person who's got the ruggedized laptop and the drone flying in the background. And what's been interesting is that, they have this small interface, and they were talking to me about the idea of, well, they'd like to look at an immersive system for controlling a drone and having that interface being presented to them to look at how we can exploit some of the, what we call the affordances of VR, AR, such as that you're embodied, you're immersed, your senses are immersed in the environment, and your hands and your body itself and your head movements are available for reasoning in that space. And what we realized as we discussed further was that actually one of the things that it would be useful for is to help them develop the next generation interface for their drone, because the machine learning interface that's presenting this plethora of information to them about a scenario may cause cognitive overload, may cause mistakes to occur, may cause the operators of the drone to be struggling with the situation, and also may not work under certain circumstances, and they need to be able to figure that out before they would implement and take to a field and live fire their systems. So why would we do this? Well, as I've touched on, and I think Ben has also touched on around the systems of the future, it's in resurgence. VR and AR has been around since before I was born. It's a 60s technology by Sutherland from MIT. Have a read of his PhD if you're interested. I wouldn't have passed it today because he didn't do any experiments, but he has one of the most influential works in the field of immersive systems. And now that we've got commodity systems, such as I said, I've got one sitting here on my desk in front of me, we're able to place a person inside these environments and read off their body. We're able to read off their various aspects of the way they use their body and how that's connected to the way they reason in the world and how that may influence their behaviors inside the system. And the reason we can use that is because a user interface, of course, is a major part of the human-computer interaction with its visual nature. And there are constraints when you're trying to run this on a laptop. And so what we can use this environment to do is actually simulate that interface inside a virtual environment. And then we're able to evaluate, does that user interface work in an optimal manner? We're then able to determine what's the operator's capabilities using that interface in various configurations. But then we're also able to work the other way and confirm, does the drone perform effectively in trained with the operator at the same time? And so one of the things that we talked about in this idea is that this is commodity hardware that's available now. So some of this is about trying to think about what's coming in the future. What I would like to say as well is you can start now on these interfaces. The first step is quite available. On my own impoverished academic budget from my university, I can equip my house now, set it up as a complete virtual laboratory, and I've been using it for developing various applications in other areas as well. And so, something that could be used for a system like this, it's less than 20K to cost. And this opens up all sorts of possibilities. You're not needing the bespoke software and hardware that is required previously. Interestingly enough, just yesterday I was talking to a captain from the Defence Forces, found out that he and his team do tank simulations in my favourite game, War Thunder. And I found that interesting. I was waiting to hear whether people are using commercial systems now to get their teams ready. Last but not least, this is now a current technology for games. Games are evaluated using these systems. Websites are used by biometric analyses of environments, and vehicles, all sorts of vehicles such as aeroplanes and cars. The research centre at QUT that works with cars also looks at using virtual reality systems to evaluate the interface of the car itself. So this is already being used. And so the idea that we're looking at here is some of what Ben was talking about. What can we gather from the environment, and how would the framework work in order to produce a training system for people to use? And it's not a big reach to build this now. So we have over on the left-hand side our soldier who's got a headset and their rugged laptop that they're holding in their hands. And what we can do is we can track those laptops. You can track physical devices and pull them into virtual realities. I've got a tracker here. You attach it to any hardware device you want, and suddenly when you're inside the virtual reality, you can, as well as feel that laptop, the thing that's in the environment corresponds to that item. So here we've got the ability to be able to take that laptop into the virtual world and then pop them into whatever scenario we want. We can, of course, then simulate the drone itself, and then putting it through the magic of machine learning, coming out with the user's conformance to the tasks required, the drone's conformance to the intentions of the operator in the scenario, the actual assessments of the user interface. So that means that the user interface can be, in a hard sense, confirmed against a large group of warfighters, or can be personalized, as we see down here, to that particular warfighter in that point of time in their training. People's capacity for using interfaces changes over time. There's a classic scenario of this that's often cited from the medical literature, where they looked at what people looked at in X-rays. The novice looks everywhere. The expert immediately hones in on the anomaly in something that they're searching for. And this is key to all sort of environments that people are familiar with, and therefore presentations of information are different at either stage along those lines. And so we see that this sort of system, with its ability to track what the person is doing in the environment, in a very fine-grained manner, start to hone in on those ideas. Moving on. So what can we get out of just a system now? We can get eye movements. I have a pile of headsets at QUT where I'm able to simply track people's eye movements. And in fact, we've got people controlling games with their eye movements as a nice test user case. You can also track their hand movements. So if it's a tactile interface on the, the touch screen or whatever system is being used, we can track that. We know where they're using their hands, whether there's some dexterity issues, blah, blah, blah. You can also capture their body movements. And the body movements may or may not matter to this scenario, but they may indicate stressors on the person and agitation. These are some of the emotional feedback mechanisms you might be able to see. This person is overloaded. Let's have a look back at the data. And last but not least, of course, you can extract out things such as high quality heart rate measurements, audio capture and stress analysis from the audio coming from the environment, and galvanic skin responses, or whether the person is sweating heavily under stress in the environment. So the beauty of these immersive systems is we're able to capture that now quite well, and this improves as we move forward. So some of the things you could think about in the future is that feedback may come through the whole body. Imagine an urban warfare situation where a squad is trying to work their way through a suburban environment. It could be that they're aware via various telemetry systems that there's a squad of 3 opponents beyond the wall. But if you try to communicate that to people visually, it might be distracting. So why not put a haptic vest on them and they feel the enemy from another location? And they're able to respond to that without any communication between each other, because they've practiced the scenario and they know the feeling on their body where there's an enemy over there to deal with. So this can be captured now. There's a lot of other information, a lot of interactions in these immersive spaces that can be further enhanced as we move forward into the future. But as we can see there on the right there's an example of an aeroplane interface being examined using these eye and head movements for its capacity as a flying machine. So the idea being here that you can assess the cognitive load in some very realistic situations. Now, the key thing about immersive systems, and probably in the defense sector, you're heavily invested in this. You're aware of the classic fact that you can place your fighters inside dangerous and expensive scenarios and let them practice to mastery. So in this regards, with even a hardware interface like a laptop tracked in the world, you're able to put them into a distracting scenario where they're dealing with the interface, but they may be under attack. They may be trying to discern where an attack or an ambush is coming from using the drones. So therefore, you can simulate that to see if the cognitive load of the user interface is still too heavy for the person. You can also therefore see their executive attention, their gaze, where they're looking at user interface elements inside the interface for the drone. And the idea then would be you can modify them. You can move them into the person's regard and enable them and assist them to actually make decisions better. So for instance, some of the things the guys were showing me were quite a heavy cognitive overload. They're trying to figure out how to present that to the warfighter clearly. And also being able to correlate that with the performance of the operator and by machine learning or statistical analysis. So one comment on AI that I have to say is that often it's not a magic thing. Often just good statistical analysis and correlations between features and things the person has done in the hands of a trained trainer can provide a lot of insight into what the person needs to do to go to the next level. And then we can encode that in a synthetic agent moving on. And last but not least, this becomes like an test environment for the drones of the future. Drones are going to be a major part of warfare moving on now. Australian military is already having to deal with configurations whereby squads are attacked by piles of drones, and what are their defense implications? What are their abilities to posture in a defensive manner in order to deal with these threats? Here is a situation where we can start to test that effectively in a way that will enable people to have optimal interfaces to counteract, the drones that they're being attacked by. So last but not least, I guess I wanted to, I've touched on it already. The idea of using machine learning in these environments, I don't see it as a magic box. My first slide to my students in the final capstone is, there is no magic. Machine learning is not magic. Machine learning is good statistics, finding correlations between events, and then processing them appropriately based upon a correct model of the world, an epistemic or ontological model that says, this makes sense, you might want to deal with it. And of course, having constantly changing interfaces is always a potential problem, but it's also something useful. And each use case needs it to be analyzed correctly in order to move into the future. YouTube profiles is a classic humorous one. The things that pop up on your YouTube profile from personalisation sometimes is wrong. You don't want that to occur inside a warfighter's interface. So that needs further work and further insight. And also, there's also open questions about, does virtual reality affect how you derive the training information? One of the things we have to figure out moving forward is the quality of VR is at a certain point here, but it is improving every 6 months. New products are appearing. So when we move into the longer term future, what sort of interfaces are we going to have there? We probably need to be looking now at the effects of these systems on people's cognition as we're testing environments and putting simulators in front of them. And last but not least, this is very useful with CV4 testing in the field. So this is where I think the power of this sort of garnering of information from people is that you can get them practicing. And one of the modes we talk about when I go to industry is the idea you can get people practicing at home before they even turn up to your workplace. They can go to your workplace, they've done the safety, health and safety checks, they're aware of the structure of the environment so they don't get run over by a large truck or something like that. And all those things can be presented remotely using modern technology. And we found out with COVID, and COVID is one of the big fillets for VR at the moment in time, is that, well, these immersive systems give us superior remote capabilities. But there's more coming, and we need to be prepared for that. And so part of what I say here as a sanity check as well is that for the scenarios that Ben has been talking about, we need to start preparing now about how to use this data effectively to actually chart out the map as we move ahead. But such things as user interface checking and user interface conformance and drone conformance can be performed now, and I think to a high level of validity. But we need to think about moving forwards about how that's going to become part of the major training systems in the future. Thank you very much, Kate. Any questions, feel free to email me if you want to chat.
That's great. Thank you so much, Ross, for that presentation. While I'm waiting for a question from the group, maybe Ricey, you can respond to your thoughts with regards to Ross's presentation.
Yeah, that's a really nice follow-on, Ross. there's a lot of really good points in there that I was trying to jot down some notes as we went for some conversation later on. One of the things you talked about was the experts focusing on a certain part of an X-ray or honing into that immediately. And one of the things that we've looked into as a particular exercise is chess. Not because I'm a chess nerd, so I shouldn't probably try and shy away from that too much, but there's a really nice measurement of how expert the person is and where they hone into, because chess has a really nice rating system that's been around a long time. And I think that's where you talk about that expert honing in and getting your measurements from that X-ray is really interesting in that space as well. And also, I like where you're talking about the types of systems that are available now. One of the questions that popped up before in the chat I saw from Rodney Pilgrim was about, is this going to increase the workload or decrease the workload of the operational trainers and the people that are imparting this knowledge right now? And in a really unhelpful way, and I'd like to see your thoughts on this as well, is maybe both, because I think in the immediate term, it's going to increase the workload of those operational trainers, because it's not just pull out lesson 13 and just go and deliver lesson 13. It becomes a very adaptive process of each day is slightly different, which shouldn't be a huge problem for operational trainers, because it's that's how operations work. It's different and constantly evolving, and days change. But on the other side, if we can get people through courses in 60 to 80% of the time, because they've only done the lessons and met the competencies that they need to do, because they're not repeating the things over and over again that they've already met, then holistically we're reducing the burden on the system. Did you have any thoughts about that? Because I know you talked a lot about the current available systems and where we're going and how it's evolving every 6 months as new stuff. Do my thoughts fit with you there, or do you have a different idea?
No, I think it's valid. I think one of the interesting things as an academic is when you start out, you spend a lot of time generating content. And as you get further and further into your career as an educator, you get more about asking biting questions of your students to make them think about how to progress. And I think that could be, well, I'll use that as a metaphor for what might happen to the role of an educator, because I think content is less and less of an issue for educational scenarios. It's just that ability to be the expert, to come in and go, yeah, I saw how you missed that target over there. That's a classic. I've seen that 10 years in a row. And you might want to, when you come into this situation, do some sort of surveillance check and not go for the obvious target because they're flanking you. I mean, that's a poor example, but it's just an example of you see the patterns. Yes, a machine learning system might pick that up, but I think the role then of the educator is also they're the human talking to the person, because it's one of the we respond well to human input.
Right. Yeah.
It's one of the things we do, and I noticed that my job as an academic is less. I don't do any technical teaching anymore. I'm just the person urging them on, and then pointing out you've made that classic mistake there. Go here.
Yeah.
And so now that's very broad brushstroke, but if you're getting the feel of what I'm saying, I think it comes beyond the delivery of a straightforward, like I've done, straightforward set of slides, and it's more about these discussions and turning the person towards, their weaknesses or enhancing their strengths.
Yeah.
And I think that would be more and more the role, because the content can be generated.
Well, I mean, that's a really nice point, because it seems really adaptive, right? Where the human state monitoring almost informs the expert and helps form their judgment to impart on the student. And I think that's part of the loop that's really important to particularly in the near to medium term, is the monitoring state will inform the expert to then cast their judgment on that to impart knowledge.
Yeah, I mean, I guess it'll be, especially in this round, and of course it's used already with video replays, but you can imagine augmented video replays with cognitive states being inferred via the eye movements and so forth, and being able to then, the trainer being able to look at that in detail and take the person through. Here was your break point. You didn't quite nail it here.
Right.
Yeah. Yeah,
I'd
fantastic.
just ask a question from the group chat from Kustab again, or Kustab, sorry if I'm mispronouncing your name. Coming from a technology provider perspective, what do you think are the key activities that need to be undertaken in order to assess and communicate the explainability of AI systems? The field of computer vision has been exploring this with specific techniques to visualize deep neural networks, but this may be difficult to convey to non-technical partners. So how do we work to bridge this gap? And this question has been asked in the context of being able to understand how a particular interface is intended to be used and why it's presenting the information that it does to maximize or optimize engagement in the interface.
That's an excellent question. That's an excellent question, because that's one of the, I think, it's one of the great use cases for augmented reality and virtual reality systems, is to be able to, so if we were to have an augmented reality version of this scene, it's the classic scenarios of face analysis, listen to the stress in the voice, you get an idea of how Ross is feeling, but maybe there's other information that's come in, such as histories and so forth of the interactions between the machine learning system and the person, that enables them not just to see the internals of, hey, here's all the convolution operations inside the deep learning neural net. Probably not what's needed, but it might want to show some sort of higher level reasoning process. Kate's probably going to laugh at this. A higher level reasoning process. This was represented more abstractly, that simply says, well, the machine learning system thought that Ross was in this state at this time, so it presented this. And then a human, who is probably the last authority on being human for a while yet, will be able to interpret that and then be able to present that, to the student, say, hang on a minute, you weren't thinking correctly here. So I think the ability to visualize intention inside machine learning systems is still in its infancy. I talked to the roboticists at QUT about this. They have robotic arms, and they want to know what the machine learning system's thinking as it's moving around, so they can understand, and it's even a simple debugging tool. So I think it's a deep question, and I think there's a lot of good work to be done on getting that reasoning in a human digestible form to a person, so they understand the system and why it's making these decisions. It's an open question. It's a nice research project.
Yeah.
I'll propose it as a research project. Yeah.
I think it gets to cognitive bidirectional understanding as well, because individual humans have different abilities to do things like visual imagery. So there's some really nice research studies on fMRI examinations of what parts of the brain light up when people are trying to imagine and remember images. And we do actually have some introspective access on how badly or well we do these things, or rotate images in 3D. And so if you know your operator is poor at mental imagery, then be careful about the way you use visual information, right? Maybe you're better to use that audio or that text-based information, because that's something that the human operator will be faster at understanding in any explanation provided of an AI. So we've got another question from the audience. So as we take up the acceptance of introducing TAS, so that's Trusted Autonomous Systems and AI, into the combat environment, how do you see the governance and V&V framework taking shape to address fluent and dynamic changes in rules of engagement, largely due to an unpredictable and arguable, less moral adversary? Yeah, that's a biggie.
That's a biggie. That comes into an ethics framework. So I have to say I'm going to struggle with that one, because while I'm aware of the ethics issues in AI and the trying to match rules of engagement in the fog of war around those environments, I can't speak with any authority. All I can suggest then is that maybe the AI becomes an advisor, and then human authority has to these are ethical considerations that one would imagine a group, battalion, or field general would have to make decisions after they've been heavily trained about what the possibilities are. That would be my only statement back. I think there's still, we still accept at the moment that humans must be in the loop on these determinations, which brings with it all sorts of problems that have to be addressed. But it would be interesting to see, what is interesting about machine learning is, of course, it's still a little bit brittle. So for it to be that flexible and starting to be human brings up all sorts of potential frailties. So, you know, the strength of machine learning is probably that it's able to predict quite well under various circumstances and outperform people. Chess is an example, as Ben would like. There's all sorts of scenarios now where it is taking over, but one would imagine the around intentions, that's got to be still a tough one to sort out, because it will pick something optimal. So that always the classic doomsday scenario is wipe out humans and it solves all the problems of the planet. And you know, this is not one that we want. So we go back and say we reject that and have to, you know, make some sort of other negotiation.
I'm going to ask the next question, and I'm going to give Rice the opportunity to respond to both the question we've just had and the next one coming up, because it comes from a combat perspective, Rice. And I think as Ross has declared, he hasn't got a military background. So as we finish up, I think your perspective might be really welcome. So this is from Paul Hornsby. Defence is particularly interested in the ability to accelerate or decelerate AI support given a particular combat situation. That is for AI or ML to change gears on the fly. How hard is that to achieve technically? Because if achievable, it reduces training burden or question mark.
Right, that's a really good question. And I have to caveat this with I'm not an AI specialist. My part of this system is being able to take inputs and outputs and understand competency sets of how to generate curriculum and learning standards and develop that process, a certain input or output. How easy is it to change gears? It's a difficult question. And I guess it depends on whether you're talking about a generalistic, like with the future state that I talked about, there was this general teammate that was understanding of all circumstances to do with your particular job role and career as you move forward. And then there's the more near-term application of a very specific autonomous system that is very good within the bounds of what it was granted and nothing else. You know, just because I keep using the chess example, and Ross so eloquently added that in there as well. I mean, machines can beat humans at chess because it's a defined bound of knowledge and application. As you expand that out, the variability and your required variables increase. And so that becomes very challenging to fit into a box or a black box of mystery. And that probably comes back to the question that Korstar, apologies if I got that name wrong as well, asked, which was all about transparency to me. How transparent is the algorithm in that system, and the transparency may lead to the ability to understand how and when to indicate to the artificial system or intelligence when to change gears and what's appropriate and why. But I think we struggle with that as well because we don't truly know how humans work. Humans aren't perfectly transparent either. You know, it's quite hard to see your junior bog rat or aviator. They do weird things all the time, and they can't often tell you why they did them either. So it's interesting to see everyone want perfect transparency from an autonomous system when we accept different standards with people over time. And I think that comes back into the ethics of what's acceptable and what's not. And I tried deliberately to buy out of that with the ROE question in my presentation because it's really fraught with danger. The only thing I will say, and I'll leave it to the experts like Kate, because we went to a seminar run last year by TASDCRC on exactly this ethical AI stuff that was run by Kate. And I remember not only Kate talking about this, but several other presenters about what is ethics in AI and where should the boundaries be set. So as far as I'm aware, and I could be completely wrong, we're not quite sure yet. And there is some serious work in the epistemology world that needs to go into that.
Thanks, Ben. Any last comments? We're just finishing up in our final minutes. So to both of our presenters, Ross and Ricey, apologies to anyone in the chat who hasn't had their question answered today. But last comments, and then I'll call the meeting to a close. Ross, Ben.
Oh, sorry. Yeah, no.
That's fine. You don't have to have any.
No, I was thinking you were going to make some final comments. Okay.
No. Up to you.
My response on the ramping up one's an interesting one because that's a dynamic sort of adjustment problem, which is like a metacognition approach. But it's interesting because so much of warfare is reliant upon the human condition and the emotions and so forth. And morale is not a concept for an AI, supposedly. And suddenly the nature of combat changes. And so people who are, you see atrocities occur in warfare due to, emotional states of people. And then you see defeat occur or victory occur due to emotional states. It's an interesting question how it becomes, I think, a meta-optimization problem. The AI would simply look at its resources, look at the intents of the commanders, and will be making decisions, moving towards the goals that have been set inside the theatre of war. It'd be interesting then to think about optimizing at that level would be a big research problem. Back to general comments. Look, I think it's an interesting one to see how, the idea of streaming data out of people and using that for user interface assessment is a sort of current problem in computer-human interaction. There's lots of papers coming out on that now. We have a project on it, and there's lots of use cases. And I can see that, it lines up well with the whole idea of how are we going to get data out of people in an effective manner. And part of it is to see them in action, to see the whole bodies and the whole, components of them in action. But yes, there's still some quite deep problems to solve about how you use that data, because just because an optimization algorithm decides that, well, the person was in this state, still needs to be reasoned out from the perspective of subjective human existence. And that's still the purvey of humans, because we're the ones who experience that. And I'll leave it there.
Thanks, mate. All right, Ricey, 30 seconds.
Oh, look, I'll leave it there, Kate. If I talk any longer, I might start getting excited about and talking about the football getting back on tonight. So I'll leave it there. But hey, thank you so much for organising this, and thank you for having myself on here. This has been great.
Thanks, everyone. I'll record the recording of the video, and I'll record the questions in the chat. So please stay in touch with the centre and with our speakers, and have a lovely day. Thank you.
Thanks very much, mate. Thank you. Thanks, Ben. Thank you. Bye-bye.